discussion.
In industry, we try to solve the real problems with no assumptions in mind, and we want to go as close to the reality, right? And there is no there is no planning to do some research or publications or patent. If there is something which can allow our industry, our kind of management to publish, then only we publish. Otherwise, we don't publish at all, right?
So India has been doing great on the space data, on the satellite launching side. So how much progress have we done? Like how did you start in the space data analytics, and how much progress did we make in this field? If you can give us some idea.
Yeah, actually we have been using this data. Different data sets are coming up, and if you see the entire trajectory, as we are pointing out, of the Indian space research organization growth, and how they have been culminating. So you can very well see that with passage of time, we have been adding to more advanced sensors, more complex payloads, and not only in terms of the payload development, but also the way they are acquiring the data. So earlier, whether it's a push broom kind of a scanning, where we are taking the entire scan and then brooming it forward, or we are doing a line by line scanning. So apart from like different scanning approaches, then what are the different sensors like radar sensors, like and also our imager and sounder. So these type of different sensors are coming into picture, and with that we are actually getting so much of data, and these data in terms of different bands, hyperspectral, we are trying to get into the foray of hyperspectral. So we are basically trying to get the Earth atmosphere system. We are trying to portray that or reconstruct that using all these data sets.
Right, wonderful. We can all understand. We are all, users of the satellite communication. So yes, that's definitely one part. But another part that interestingly both Dr. Das and Dr. Shukla, both of you talked about is the agricultural part. Now, when we talk of, I would look at it from the research point, but maybe we can look at it from the modeling point also. When we are trying to solve problems for agriculturists, suppose we think of providing, say, what kind of crops to grow on a certain land, right? This kind of advice. It is possible, right? But there is one difference between other countries, Western countries and India. That is the size of the land holdings, right? So in India, usually the size of the land holdings is very small. So they would need much more precision when we come up with such advices. So how do you take care of that?
Technology point of view, there is no barrier. Only barrier is that who will bear the incentive, right? There are solutions, and those solutions, some of the solutions, really great solutions out there as a free of cost. There is no cost associated with it. Now, there should be, farmers should be educated enough to know some of these solutions and adopt it from their farm. But this gaps between what is there versus what is adopting by farmers in this space of this part of the country is really a big gap, right? Here, I guess this analytics conference is a very nice platform to take some notes that what they can do also, right? For example, the government is doing something called soil health card. They are giving soil health card to each and every farmer across the country, right? Periodically or couple of seasons gap, they used to do all the sampling, collecting the soil sample and do this testing in the lab. They give soil health score, right? So to say, different kind of component of soil properties, like how much nitrogen is there, phosphorus is there, potassium is there, how much organic carbon is there, how much boron, manganese, all sort of macro plus micronutrients are there in the soil, right? I think there is this gap also, we don't expect that some foreigner will come and some, others global university will come and use this data to build some analytics. We need to build analytics with our local data. So this is also integral part of ESG reports. Generally, we understand ESG, right? Environmental, society, and governance, right? Under environments, right? There is a GSG key component, and that's the most important components to have that numbers to be reported to the. For example, SEBI, they come up with for this year only, right? 2024, each and every organizations, industry, how much GHG emissions they have to produce this number. Like there was this bottom-up approach method, right? Each of sources of emissions, if whether it's a power plant, city, or some industry, they used to collect all the auxiliary or proxy data related to the emissions.
Dr. Shukla talked about the natural disasters. So, how can we use satellite data to say, can we avoid natural disaster or at least predict natural disasters and be more prepared for it? Or maybe even post-disaster, how can we use this data? So if we can share something.
Yes, it's a very good question. And these are the three pillars for disaster management. Is if prevention is there, or whether we early warning kind of a system is there, and after a disaster has occurred, then how do we go about damage control? So while preventing, this is for weather systems. Usually, those are drastical technological things are also coming up, like cloud seeding or weather modification kind of things are also coming up. We are also working on that using our space-based inputs. But on operational basis, the two things we are targeting is early warning systems, development of early warning system, weather nowcasting, and short-term weather prediction system. These are the three things which we are working on, and after a disaster has occurred, then we go about this our disaster management towards damage control. So when we go for prediction of any disaster, so any natural disaster will be lot dependent on the scale of the natural disaster. For example, cyclone is a synoptic scale disaster. So it will stay in the system for 10 days, starting from the genesis to the landfall. So first is to predict the genesis. How do we go on predicting the genesis, and how is satellite important that way? So satellite may be the only source of observation when we are talking about synoptic scale, because there will be before genesis of our starting of a cyclone, there will be certain signatures which we can observe through ocean winds, ocean surface wind. So surface winds will take a particular structure due to the vorticity, and it is kind of, you can say, it's elliptical, and then a circular structure will be formed.
Difficult to do anything, right? Your noise has to be in some threshold, right? And of course, the advancements is happening to decrease that thresholds day by day, but this will remain forever. And one has to see that what is my application demands, how much I can tolerate, right? That will be another input for taking this noise into consideration. But noise will be there forever. Yeah. For some cases, noise is not so noisy. Some cases, okay, we can consider this noise as well.
Thank you very much.
That was a great point, because what you're talking about is a sensor noise. So sensor will definitely have some noise, and apart from the sensor noise, when we process the data, during the processing of the data also some noise is introduced. So that you can remove by post processing of the data. But of course, sensor noise will be definitely there. For that, we see signal to noise ratio, all those things come into picture.
Okay, thank you very much, Dr. Das, Dr. Shukla, and Professor Bagchi. It was wonderful having you, and I believe the audience enjoyed it. There were so many questions. Thank you very much.
Thank you for having me.